Welcome back. In this video, we will learn about ionic compounds and how to name them. Starting off, what is an ionic compound? Well, we have learned that compounds are made of multiple elements in a fixed ratio. An ionic compound is simply any compound that is formed from cations and anions. Now, all compounds are neutral. That is, they have no overall electric charge. So how is this possible when ionic compounds are made entirely from charged ions? Well, in all ionic compounds, the positive charge from the cations must be balanced by the negative charge from the anions. And we can make sure to balance out charges when we determine the formula of our ionic compounds by using what we call the crossover rule. So let's try an example. What is the formula of a compound made of magnesium ions and chloride ions? Now, magnesium is in group 2A. And therefore, it will have a charge of 2+. Chloride is a halogen in group 7A, and it has a charge of 1-, or just minus. So what we're going to do with our crossover rule is take the amount of charge from our cation and use that to determine how many anions we will actually make. We'll do the same thing. The amount of charge on our anion will give us the number of cations, MgCl2. Note that I didn't actually write a subscripted 1 for our ionic formula. It's just implied. The formula that we have here on the board lets us know that there are 2 chloride ions for every 1 magnesium ion. Now, in ionic compounds, the ratio of cations to anions is given by the formula. However, this does not mean that there is only 1 magnesium ion and 2 chloride ions. There may be 1 million magnesium ions and 2 million chlorides, or more likely, an even larger number. Only the ratio is important. The formulas of all ionic compounds should be written with the simplest possible whole number ratio of ions. This is known as the empirical formula. Now, one formula equivalent of an ionic compound is known as a formula unit. Let's do another example. What's the formula of a compound made of barium ions and sulfide ions? Well, barium is another 2A metal, so we're going to have barium 2+ ions. Sulfide, remember IDE is the ending of our anions for monatomic species. So this is from sulfur. Sulfur is in group 6A and has a charge of 2-. Doing our crossover rule, we're going to get 2 sulfurs and 2 bariums. However, this is not the simplest possible whole number ratio, so we're just going to go ahead and simplify this down to BaS. You may have noticed in all of these cases, the cation is always written before the anion. And whenever we name these binary or 2-part compounds, what we're going to do is simply name first the cation and then the anion. So MgCl2 is magnesium chloride and BaS is barium sulfide. Let's do another one. This time we're going to determine the formula of cobalt-3 sulfate. Now, cobalt is a transition metal, but I explicitly gave us the charge 3, so this must be cobalt 3+. And we memorized sulfate as one of our polyatomic ions earlier, SO4, and sulfate has a charge of 2-. So we do our crossover rule. We're going to get 3 sulfates and 2 cobalts. Now, I said we have 3 sulfates here. That's going to give us a total of 3 sulfurs and 12 oxygens in our formula. But you might have noticed that what I wrote looks a little bit like I have 2 cobalts, 1 sulfur, and 43 oxygens. Now, that's not right. So in order to show that we have 3 sulfates, we're going to put parentheses around our polyatomic ion. CO2, SO4, 3. These parentheses should always be used if there's a subscript associated with a polyatomic ion. And remember, when counting the number of atoms in our formula, you're going to actually multiply the number outside the parentheses by the number of each element inside. Now we can also determine the name of an ionic compound from its formula. So, what is the name of NH4, parentheses, 2SE? Well, if this is the result of making a compound from its elements using the crossover rule, let's just split it back up into the ions by reversing our crossover rule. That means that I'm going to have 2 of my anions, and in this case the 2 refers to the charge, 2 minus. I only have 1 selenium here. Remember that that 1 is not written in place, which means that I have NH4, 1 plus. Now, NH4 plus is the ammonium ion, and Se2 minus is called selenide. Therefore, this compound is named ammonium selenide. Let's do one final example. What is the name of Ti, parentheses, CO3, 2? Well, again, we can split this up into our ions. So I have a 2 plus charge with my titanium. And with 1 titanium, I must be making CO3 minus. There's a problem here, though. CO3 minus is not one of our polyatomic ions. You should remember that we have carbonate, but carbonate is CO3 2 minus. Now, if this is my anion and I have 2 minus charges, then the total charge of my cation must balance that out, and I must have titanium not 2 plus, but 4 plus. What's the name of this compound? Well, it's going to be titanium 4, we have to specify the charge, carbonate.